Okay, so we're given some information about three different firms, and we want to kind of sketch what their isoquants probably look like and see what we can say about their marginal rate of technical substitution. So the first one is a firm can hire only full-time employees to produce its outputs, or it can hire some combination of full-time and part-time. Each full-time employee let go, the firm must hire an increasing number of temporary employees to maintain the same level of output. Okay, so they can hire part-time or full-time, but as they let full-time guys go, they need more and more part-time guys to replace them. So it's going to have some sort of curvature, their isoquant, something like that. So as they let these guys go, at the beginning, it's easy enough for them to swap maybe one for one or two part-times for one full-time. But as they move more towards this side, it takes more and more part-time guys to fill the shoes of the decreasing number of full-time guys. So what we say about the marginal rate of technical substitution, well, it's just like what we said. So as you move more towards having only part-time guys, to give up another full-time guy, it's going to cost you more in terms of how many you have to hire. So there's a diminishing rate of diminishing marginal rate of technical substitution. It costs you more and more in terms of one input to swap for the other. Okay. So part B is a firm can always trade 2 units of labour, so sticking that labour down here, for 1 unit of capital and still keep output constant. So these guys are going to have just straight line isoquants, something like that. They can always swap, no matter where they are, labour for some fixed proportion of capital and vice versa. So there's no increasing difficulty in swapping one for the other. It's always a fixed rate. So say, what we say about the marginal rate of technical substitution, if they can always trade 2 labour for 1 capital, then the slope of this is just going to be a half. And so the marginal rate of technical substitution will be a half. So it's a constant slope, so it's a constant marginal rate of technical substitution, unlike this one where it will be different depending on where you evaluate it. This is going to be always a straight swap of whatever the proportions are. Part C then is a firm requires exactly 2 full-time workers to operate every piece of machinery, or each piece of machinery in the factory. So these are people this firm needs things in a fixed proportion. So it's just like if you think back to utility, where you only get utility of having left shoes and right shoes in a fixed proportion. Here you only can make something if you have fixed or corresponding numbers of each input. So these things are just going to be these Leontief type things, right-angled L's. So, you need two workers and 1 piece of capital gives you the same as 8 workers and 1 piece of capital. These are all in the same isoquant. So that's how you kind of figure out what kind of shape things are likely to have. What about the marginal rate of technical substitution at these? Well, along the vertical parts, it's undefined. Okay, there's no slope to that thing. And along these, the flat part, it's equal to 0. So this is just like the utility case where you can't differentiate these things. You just have to suss them out.